short introduction, you can watch how I made a custom board, a custom CAN module that I'm going to use on top of this USB to CAN by Innomaker. So I've been using this module for a while, and but I want to create my own board to for a certain application or custom application that I'm planning to do. So so this board is based or similar to the one that is already mounted here, but I want to create my own custom application, maybe based on a CAN open device or node, using the CAN open node library. I can show that later. But basically, this is the module that I'm using. I have also this other module with the microcontroller solder or mounted directly on the CAN bus board. It's kind of like a carrier board and a module or a system module. And I'm gonna leave all these links in the description, but here this GitHub page where you can get all the information about these modules and some custom already applications made for Windows. You can use it also on Linux or Mac OS. On Linux, you can use the socket CAN to make it work, and it works really fine, really good. So basically, what I created that custom board, and I also created like a small sample application that it's. Now let me show you first the schematic of the board. So this board is based on this STM32L443 microcontroller. It's not the same as the one they use here. They use F072 microcontroller. I want to use this one because it's a little bit more powerful microcontroller. It has a 256 kilobytes of flash and a 64 kilobytes of RAM. And also different units, USB, 80 megahertz, and it's a nice and powerful microcontroller. And so I created my design of my board based on that microcontroller. So it's very similar to the Innomaker module. And here I have a small 3.3 volts regulator, the pin headers, LED user, just to maybe to blink it or flash it while the board is working, power indicator, the microcontroller boot selector, and the pins or connector to actually connect my ST-Link V3 to the board. So I can show you here side by side the two boards. So you can see they are very similar. Just I added just a reset button, this connector to connect my ST-Link, but you can also use one of those. Well, for the future, maybe I can use one of these, change this connector for these pin headers and connect one of those dongle ST-Link dongles that you buy on Amazon or China for very cheap. So that's the module itself is a very small board. Here it has 22 millimeters by 26. Maybe I can make it even smaller if I remove or replace this reset button and also the different connector for my STM. But basically that's what I have. So the sample application that I create just to verify that the module is working. So it is basically is very simple, nothing like very fancy or complicated. You just have my custom module that I designed on top of that CAN bus made by Innomaker that is connected via CAN bus to a Nucleo 446 RE board with a CAN bus shield on top. And this module is sending data to the Nucleo board. It's basically 8 bytes of data where this from the byte 4 to byte 7, I'm sending basically just the value of a counter that is incrementing every 0.1 seconds. And the less significant byte is on the byte 7, and the most significant byte is byte 4. So this is how I structured the data. So later, when the Nucleo board receives the data, I can decode it and send it over the USB to the PC to my computer, where I have the serial terminal, and I show the data on the serial terminal. And I have this other module, this CAN module, which is basically this one, this USB to CAN, also sending or kind of monitoring the bus or all the traffic between these two devices. So once the Nucleo board receives the data, it sends back like a acknowledgement that the data was received. And if this byte, byte 7, is a certain value, so it indicates to the custom CAN module that the data was received correctly. So that's basically what I did for the sample application. And all right, so just let me show you how the application works and how they work together. So here I have set up a simple demo application running. So here you can see the module. Here's the module which is transmitting the data via the CAN bus here to this other Nucleo board with the CAN bus shield here installed. So this one sends data, which is basically on the data of the payload of the CAN bus frame. It is sending counter value that is incrementing every 0.1 seconds or 100 milliseconds, and that counter is incremented, and every second it is transmitted to this other module. So this module will receive the data. The module, this Nucleo board, is going to receive the data, extract the data from the data that the CAN bus frame, and it's going to send that information through the UART, which we can see here, and it's going to send back to the other module like an acknowledgement that the data was received, and every time that the module confirms that the data was received correctly, it's going to flash that RX LED, and the transmission, when the transmission is completed, it's going to flash that transmission LED. So that's why you see that pattern. It sends the data and immediately receives another data confirming the reception. And this module here is just kind of sniffing the CAN bus or the bus, and it's showing the traffic between these two other modules. And here on the application, we can see the traffic between the two modules. The small module here in the Innomaker carrier board is the one with the node ID 443, and the nuclear board is the 446. So here we can see the transmission and reception. If I just close the connection for now, so you can see the data. This data sent back from the 446 module once it confirms the reception of this data from the small module. And if I send something from the other module here, we'll see how it received data, because I don't have any filter on the CAN bus on the nuclear board. So this number 5 here corresponds to this file sent by this module. If I send a different value, let's say A, which is 10 in decimal, so we'll see that value here. Because the nuclear board is not filtering by ID, it receives any data or any node that send some data, it's gonna extract that data and send it to the UART here. So as you can see, there's a bunch of messages, or the counter is almost 800,000, because it's been running for a while and close to 24 hours by now. So yeah, this is how the module works, is working. And well, later I will plan to maybe creating a CAN open node with this module and see how it works. I already have a module working, a CAN open node that I created like 2 years ago, and I can test using that. So, well, this is the module working, and well, let me know if you'd like to see something else, or a more detailed explanation on how to program the module, or any other test that you'd like to see. And that's all for now. Thank you for watching, and I'll see you next time.